Okay, today we will have a presentation by group, okay, on the project. So at first you have to identify the problem and take a case study, and you have to use the advanced analytical model. So try to get a data set and provide detailed solution using deep learning techniques in artificial neural network. Okay, and then you have to provide step by step on how data be analyzed with deep learning, right? You can use this guide as a cross-industry standard process for data mining, where you can use for your project, alright? And today we will have a project presentation with the project leader and the group members. Okay, thank you.
Hello, sir. Today, I'm going to introduce a project which is hand sign recognition using deep learning. So we are Group F. Next slide. So these are my team members. First of all, LAZARUS and HAVINESHWARN, ENOCH, NIRMAL, AHMAD, Danish, and myself, KHUHAN. So this project about hand sign recognition. So over 70 million people around the world rely on sign language, but most non-signers cannot understand it, creating a huge communication barrier. So our team development hand sign recognition using deep learning. This system based that recognizes ASL hand signs and translates them into text. So we use convolutional neural networks to classify hand gestures with the goal of making communication more inclusive and accessible in real world settings like schools, hospitals, and public services.
Problem statement, the communication obstacle for the hearing and speaking handicap underline the importance of having sign language identification technology that are easy available. While sign language such as ASL are important, most people are unable to understand them, posing social and professionally obstacles. These research and address this issue by creating a deep learning-based hand sign identification system that can classify ASL alphabet movement A to Z from photograph. The method uses a convolutional neural network CNN to accurately read a variable of signing techniques, lighting situation, and backgrounds, allows for real-time translate without the need of human interpreter. The project addressed fundamental technologies difficult such as the data pre-treatment, model optimization, and real-time applicability in order to produce a scalable solution for education, access device, and public service that improve accessibility through the artificial intelligence.
Next, I would like to present why we choose this project. So moving on to the first point. So in traditional computer vision, recognizing hand signs often required manual feature extraction. However, deep learning eliminates these needs. By using conventional neural network, which is a CNN, the model automatically learns features from raw image pixels. The conventional layer acts like intelligent filters that progressively recognize patterns from simple edge in early layers to complex hand shapes and fingers positions in deep layers. This approach not only improves accuracy but also reduces reliance on handcraft rules or domain-specific knowledge. Moving on to the next point, which is hand-focused attention. A critical challenge in hand sign recognition is distinguish the hand from background noise, especially in uncontrolled environments. To address this, the model includes a lightweight attention mechanism that teaches it to focus more on relevant regions while suppressing irrelevant background details. This attention block adaptively learns which part of the input image contribute most of the correct prediction, making the system more robust in real-world scenarios like webcam streams or mobile input where hands may appear in diverse settings. Moving to the last point, which is straightforward implementation using Google Colab. So the system is designed with simplicity in mind and fully implement in Google Colab, making it accessible and easy to use without any complex setup. The entire model from raw hand sign images to final prediction is trained and evaluated within a single notebook. We utilize a standard hand sign dataset and the process runs smoothly without requiring any manual pre-processing, post estimation, For background segmentation, using Google Colab allows for a quick experiment built in GPU support and effortless sharing or collaboration, making it ideal for education and real-world application. So next, I will pass it to Ahmad.
So I will explain the methodology of this project. For data acquisition, we use American Sign Language alphabet dataset from Kaggle. It has over 3,000 labeled images, mainly containing A until Z in 200 by 200 resolution. It is JPEG images organized in folders by class. For data preprocessing, we normalize image pixel value ranging to 0 and 1. And we also apply data augmentation techniques such as random rotations, brightness and contrast shifts, and synthetic background replacements. We also implement hand segmentation using UNet to reduce background noise. For model architecture, we built a 52-layer CNN using a standard mobile net v2. The key components are input layer, global average polling layer, which efficiently reduces the dimensionality of the features extracted by the backbone, and softmax output layer for classification. For training strategy, we use Google Colabs for model training. Data feeding strategy, we use image data generator because it efficiently loads and process image in batches directly from the directories. And loss function, categorical entropy, we use it because it is a standard and appropriate loss function for multi-class classification problems where each input belongs to exactly one of the 29 classes. For model optimization, we utilize mobile net v2 for feature attraction because it is an efficient and lightweight convolutional neural network architecture. And it's designed for mobile devices, making it very suitable for real-time application. And next, we leverage transfer learning. We use a model pre-trained on the vast ImageNet dataset. This significantly reduces training time and data requirement while achieving high accuracy. Next, we implement callbacks for efficient training. It automatically stops training if validation accuracy doesn't improve for a set number of epochs. This will definitely save time and prevent overfitting. For evaluation and result, we achieve validation accuracy of 80%, and we also improve classification of confusing signs such as M and N, and for the output validation in the form of alphabet and also confidence level.
So for project demo, here is the Python script and we will start running it. It takes some time to run, but in the meantime, we will show what kind of dataset we will use. Here we go. So this is the picture, the hand sign for B, such as this. And then this is for M. It has to be somewhat similar to the actual image itself. I'll show another one for W, which is 3 fingers. And then for Y, it will be something like this. Yeah. Right, so that should conclude for the model demo. Now we move on to the feature enhancements. Firstly, we could provide a text-to-speech feature for those that are not familiar with ASL. This way they can see what the type of, so once the person shows the sign language, it will convert to text, and then from text into speech. You can also include more gestures for actual words such as thank you or sorry. And even more, we need to use data sets for more images to improve our accuracy. As you saw earlier, certain signs get mixed up with the signs, usually for B, U, and Y. And lastly, we could also add in a text box to record the full speech with full for full sentences. After that, we'll move on to our conclusion.
To conclude, hand sign recognition successfully achieved high accuracy in recognizing static ASL hand gestures using a deep learning approach. So by incorporating techniques like attention mechanisms and triplet lots, we were able to overcome the challenges of gesture similarity and lighting variations. Our model is optimized for real-time applications, make it ready for deployment in various environments. So in the future, we plan to support dynamic gestures and sentence level recognition to make this project even more powerful and inclusive. Thank you.